In the previous algebra video, someone asked in the comment section about what this string of symbols means. As you can tell from the title, this represents a map in mathematics. However, this is neither a map for finding good restaurants nor a map for navigation. So in this video, let's construct the concept of a map in mathematics step by step and look at some of its applications. Step 1. Set. In order not to confuse beginners with too many jargons, let's assume that we already have a well-established theory about sets and its properties. Naively speaking, a set is just a curly bracket containing non-repeating elements. If there is any repeating elements in the curly bracket, it can only be counted once. Not only can we have sets, we can also construct new sets from the old ones. The most common ways are union, which means taking all of the elements from both sets, intersection, which means taking elements that are common in both sets, and Cartesian product, which means taking all ordered pairs as elements with the first entry from the first set and the second entry from the second one. Keep the third one in mind, it will come in handy later on. Step 2. Relation. Logic is the fundamental language in mathematics, which implies that a mathematical statement can only be either true or false. Therefore, a relation R of x and y, where x is an element of x and y is an element of y, is a statement that its truth value depends on x and y. Here is an example. Let x be a set with elements 1, 2, 3, and y be a set with elements 4, 5, 6. If the relation is x and y are both even or odd, then R of 1 and 4 is false, R of 2 and 6 is true, and R of 3 and 5 is also true. Step 3. Map. A map F is a special type of relation where for all x and x there exists exactly one y and y such that f of x and y is true. In other words, we can imagine that x is the set of starting points and y is the set of destinations where no one can split oneself to go to two places at the same time. We call this special type of relation functional relation. A simple example is y equals 2x squared as the relation, where both x and y are elements of natural numbers. Then we can have a table marking down which combinations of x and y generate true. Normally, we have another notation, which is y equals def of x, and we just simply call it a function. Step 4. Application. You may want to ask, if function is what we usually call it, why do we call it a map instead? To answer your question, let's go back to the string of symbols appeared at the beginning of the video. We can see that it is a map from S Cartesian product S to S itself. Certainly we can write this as a functional relation f of a tuple x and y and z, or even a function z equals def of x and y. But if I replace s with natural number and the relation as z equals to x plus y, then instead of calling it a function, we tend to call it an addition. And this is the reason why we generally call it a map rather than categorize everything as a function. So to conclude, a set is a collection of non-repeating elements. A relation is a statement that its truth value depends on the elements from each set. A map is a special type of relation that each element from the first entry can only correspond to one element from the second entry. And finally, the application of mapping in mathematics includes not only functions, but also operations. Of course, that is not all. There are a lot of interesting constructions in mathematics I've yet to explore. If you'd like to follow along my journey of teaching myself cryptography, consider subscribe this channel. If you would like to have one-on-one tutoring or coaching sessions on mathematics, physics, or other STEM subjects, you can book an appointment through SuperProf, link in the description below. And finally, if you find my video helpful and want to support me, you can give me a tip on Ko-fi or buy my merch I designed on my Etsy store. All of the links are in the description. Anyways, that's it for this time. See you in the next one.